Nearly 11 kilometers below the surface lies a place darker than space and far less explored.
At pressures that would crush steel, life not only exists, it thrives.
The deepest trenches swallow more water than anyone imagined. Tectonic, entire seas vanishing into the planet. And in the dark, something makes a sound no scientist can fully explain. Beneath the trench, a plate is breaking at a depth of 600 kilometers, and it may be changing the planet. 5 discoveries, 5 mysteries, and each one raises more questions than it answers. Keep watching. This is the Western Pacific Ocean, a place so remote that its surface gives no hint of what lies beneath. From space, the Mariana Trench is a dark arc in the ocean, a scar nearly 11 kilometers deep. At 8,000 meters, the last traces of sunlight vanish, and the water becomes a black world of freezing cold and crushing pressure. At the bottom, pressure reaches over 1,000 atmospheres, enough to crush steel like paper. This is the Challenger Deep, the deepest known point on Earth, a place less explored than the surface of the Moon. If Mount Everest were placed inside the trench, its summit would still lie more than 2 kilometers underwater. Every drop of water in this trench carries the weight of the entire ocean above it. The surface hides everything: the darkness, the pressure, the strange life, and the forces moving far below. The trench is not just a hole. It is a place where the planet consumes itself, pulling water and rock into its interior. So the impossible question is not what lives down here, but what this place can teach us about the planet itself. At the bottom of the Mariana Trench, the world is cold, dark, and still. Yet this place is not lifeless. Here, bacteria do not rely on sunlight, but on chemicals from the Earth itself, in a process older than plants. Single-celled organisms here grow to enormous sizes, visible to the naked eye, unchanged for billions of years. Even here, fragile creatures move through the black water, adapted to pressures that would crush most life. Even snails survive here, their shells adapted to the cold and pressure of the deepest ocean. Tube worms and other deep-sea life form colonies around chemicals seeping from the Earth, creating oases in the dark. Tiny amphipods, like pale ghosts, swim through the deepest waters, adapted to a world without light or warmth. At a molecular level, life here has adapted its membranes and enzymes to function under pressures that would destroy surface organisms. Sponges here are simple but ancient, filtering the water as they have for hundreds of millions of years. Even in the deepest, darkest place on Earth, life leaves its mark, proving that the abyss is far from empty. The ocean is leaking, not into space, but into the planet itself, pulled down into the deep trenches. As the plate dives, it carries water locked in its minerals deep into the mantle, where it is released by heat and pressure. The water trapped in these rocks is ancient ocean, carried down and then cooked out at depths of hundreds of kilometers. Some of the water returns through hydrothermal vents, carrying minerals back to the ocean floor, completing a cycle hidden in the abyss. Scientists now believe the mantle holds more water than all the surface oceans combined, hidden inside the rock. Every year, the deepest trenches pull down water volumes comparable to entire lakes, a slow but relentless process. It begins with a single droplet, seeping into the ocean floor, beginning a journey that will take millions of years. At depth, the water meets intense heat and pressure, transforming into a supercritical fluid that can dissolve rock. This hidden water cycle connects the surface, the trenches, and the volcanoes, moving water through the entire planet. The ocean is not disappearing, but it is being borrowed by the Earth, in a cycle we are only beginning to understand. Deep in the Pacific, a single underwater microphone listened to the darkest part of the ocean, waiting. Then it recorded a sound that did not match any known animal or geological source.
The sound was named the Biotwang, a low, metallic-like wail that echoed through the deep.
The source was somewhere in the deepest part of the trench, but no known animal could be identified. The sound was recorded repeatedly over months, always from the same region, but never visually confirmed. Acoustic analysis showed a structure more complex than whale calls, with a metallic quality that baffled researchers. Some suspected a large animal, perhaps a deep-sea whale or shark, but no known species produces this exact call.
The true source of the Biotwang remains unknown, leaving only theories and recordings. In the black water, only the drifting glow of plankton answers the sound, and the ocean keeps its secret. The Biotwang remains one of the ocean's unsolved mysteries, a voice from the deep with no known owner. Even here, in the deepest place on Earth, a plastic bag drifts, a visitor from a world 11 kilometers above. Microplastics, the broken remnants of bottles and bags, have sunk to the very bottom of the ocean. Deep-sea creatures now carry plastic particles inside their bodies, a contamination that reaches even the abyss. Plastic from the surface takes years to sink, but eventually it reaches the deepest parts of the ocean. Along the trench slopes, plastic waste accumulates, forming invisible dumps in the deep ocean. Even the bacteria of the deep now colonize plastic, creating new and unknown ecosystems on human waste. Deep sea crabs now walk over plastic films, their habitat changed by objects that never belonged there. Ocean models show that deep trenches act as traps, collecting plastic from across the entire Pacific. A plastic bottle may take centuries to degrade, and in the deep, it is preserved, not broken down. The deepest point on Earth is no longer untouched, the surface has reached it, and the question is, how much more will follow? Deep beneath the trench, something is breaking. Not the seafloor, but the very plate that carries the Pacific. The Pacific plate is tearing from within, at a depth of 600 kilometers, where pressure and heat should hold it together. The rock fractures from the inside, weakened by water dragged down from the ocean above. Water from the trench seeps deep into the plate, where it chemically alters the rock and triggers the fracture. Above the fracture, the seafloor responds with heat and movement as the plate slowly tears itself apart. The breaking plate sends seismic waves through the deep earth, signals that scientists are only now learning to read. The minerals in these rocks record the deep fracture, preserving the chemistry of water and heat at the breaking point.
The breaking plate may be linked to volcanic activity across the western Pacific, from Indonesia to Japan.
And far above the fracture, volcanoes respond, some quiet, some violent, part of a chain reaction that begins in the deep. The tectonic bomb beneath the Mariana Trench is still ticking, and its full consequences remain unknown.
In 2012, a small ship waited above the Challenger Deep, carrying a submarine built to survive the deepest place on Earth. The submersible was called Deep Sea Challenger, a single-person vessel built to withstand over 1,000 atmospheres of pressure.
The pilot sphere was steel, 9.5 centimeters thick, the only barrier between the pilot and the abyss. The submersible descended vertically, like a torpedo, dropping steel ballast to control its speed and depth. The descent took over 2 hours, through a world of absolute black, where no sunlight had ever reached. Through the window, the pilot saw nothing but black water, an emptiness deeper than any cave on land. At the bottom, the lights revealed a flat, featureless seafloor, soft sediment, and occasional rocks, a world completely still. For the first time in history, a single human reached the bottom of the Mariana Trench alone. The expedition brought back sediment samples, rich with microbes that had never seen the surface. The return to the surface took another 2 hours, but the expedition had changed our understanding of the deep forever.
In 2019, a new expedition returned to the Challenger Deep, this time with a different submersible and a new mission.
The submersible was designed for repeated dives, built to reach the deepest points of all 5 oceans.
The robotic arm allowed the pilot to collect samples from the seafloor, bringing back pieces of the deep. The descent took less than 4 hours, a faster route to the bottom than any previous mission. The lights revealed a seafloor more active than expected, with evidence of recent geological change. The expedition found fish larvae, proving that some species reproduce even in the deepest ocean. The submersible's cameras documented geological features never seen before, including fresh sediment flows on the trench floor. Each expedition has added a new line to the map of the deep, slowly revealing the shape of the world below. After each dive, the sub returned with new data, new samples, and new questions about the deepest places on Earth. The Vescovo Expedition showed that the deep is not a dead end, but a place of active discovery, still full of secrets. Every 10 meters of water adds another atmosphere of pressure, and at the bottom of the Mariana Trench, the force is beyond imagination. At 11,000 meters, the pressure is over 1,000 times that at the surface, enough to crush steel like paper. A solid steel hull at that depth compresses by several millimeters, shrinking under the weight of the ocean. A bubble of air at the surface would be crushed to nothing long before reaching the bottom. Even objects that sink to the bottom bear the marks of the pressure that shaped them. The water at the bottom is dense and cold, pressing down with the weight of an entire ocean. Life here is built for this pressure, with molecules and membranes that stay stable where ours would fail. The rock itself is compacted and heated by the pressure, forming minerals found nowhere near the surface.
Submersibles must flex and compress with the pressure, a controlled collapse that keeps the pilot safe inside.
The pressure of the deep is not an obstacle to life. It is a condition that life has accepted, and in accepting it, below 1,000 meters, sunlight is gone, and the ocean becomes a world of absolute darkness, cold and still. The temperature at the bottom is near freezing, only a few degrees above zero, constant and unrelenting. In the darkness, some creatures produce their own light, tiny beacons in the abyss. The water here is a chemical world, rich in minerals and nearly devoid of oxygen, yet still alive. The water column is layered like an invisible landscape, each level with its own temperature, pressure, and chemistry. Marine snow, the remains of life from above, falls slowly through the dark, feeding the creatures below. In the dark, fish have evolved without eyes, relying on touch and pressure to survive. Even in the dark, heat from the earth creates oases of life, where organisms thrive without sunlight. Light in the abyss is a language, a way for creatures to communicate in the permanent dark. The darkness of the Mariana Trench is not empty. It is a place of hidden light, hidden life, and hidden questions.
The scientific explanation begins with plate tectonics, the slow engine that creates trenches, fractures, and volcanoes.
The missing water is not lost. It moves through a deep planetary cycle, from ocean to mantle and back again.
Extremophile bacteria thrive because their chemistry is built for pressure, not despite it.
And the Biotwang travels through layers of different density and temperature, which can distort sounds in ways we are still learning to map. Plastic reaches the deep because ocean currents carry it there, and the trenches act as natural collection points. Minerals formed under extreme pressure and temperature record the deep processes that shape the trench. The science of survival here is written in cell membranes and proteins, adapted over millions of years. The seafloor is not static. It shifts, settles, and records the slow processes of the deep. The trench itself is a product of time and motion, a wound in the planet's surface that has opened over millions of years. Science does not remove the mystery of the Mariana Trench. It deepens it, showing us how much more there is to learn. The Mariana Trench is not alone. The planet is crossed by deep trenches, each one a world of darkness and pressure. Trenches like Tonga, Kermadec, and Java share the same origin, but the Mariana Trench remains the deepest of them all. The Tonga Trench, nearly as deep as the Mariana, holds its own secrets, its own strange life, and its own unanswered questions. The trenches are the counterpoint to the mid-ocean ridges, places where the planet's crust is destroyed rather than created. The trenches are part of the Ring of Fire, a planetary system of subduction, volcanism, and earthquakes. Deep-sea volcanic glass preserves the chemical signature of the mantle, revealing processes far below the trenches. Every trench has its own chemistry, its own geology, and its own forms of life, shaped by the same forces in different ways. The trenches are the inlets of a planetary engine, where old crust sinks and new crust is born far away. Above the trenches, the surface gives no clue, but below, the planet is working, slowly and ceaselessly. The Mariana Trench is not an anomaly. It is a window into the forces that shape every ocean, every continent, and every living thing. We have seen 5 mysteries of the Mariana Trench, but each one opens into deeper questions that science has not yet answered.
The sediment of the trench holds records of ancient oceans, but we have only begun to read them.
Only a tiny fraction of the trench floor has been mapped in detail. The rest remains unknown.
Robotic explorers have begun to map and sample the trench, but they can only cover a few meters at a time.
Many of the species here have never been seen before, and some may never be seen again. The source of the Biotwang remains unknown, and with it, the identity of the voice from the deep. The chemical processes inside the trench wall remain partly unknown, with new minerals and reactions still being discovered.
Even in the stillness, the trench is alive with slow, hidden processes we are only beginning to detect.
The tectonic bomb is still active, and what it will do over the next million years is unknown. The remaining mystery is not what we found, but what we have not yet found, in a place that has barely begun to be explored. The future of deep-sea exploration belongs to machines that can go where humans cannot, and stay far longer. New sensors can measure pressure, temperature, and chemistry at the bottom, sending data to the surface in real time. Swarms of small robots could one day map the entire trench floor, working together like a single organism. Permanent observatories on the seafloor now monitor the deep continuously, capturing changes no expedition could see. Digital twins of the deep will let scientists explore virtual versions of the trench, testing ideas before sending robots down. Fiber optic cables on the seafloor carry data from the deep, but they could also act as sensors, detecting earthquakes and currents. New drones can dive deeper, stay longer, and send back high-resolution images in real time. In the far future, habitats could allow researchers to live on the deep seafloor for weeks, observing the abyss directly.
The mapping of the deep has already begun, and with each pass, the darkness gives up a little more of its secrets.
The future of exploration is not just reaching the bottom, but understanding it, and the Mariana Trench will be one of the great frontiers of the century.
We began with a single bubble, rising through the dark. A bubble, rising from the depths, carries with it the memory of the abyss, and then it is gone.
5 mysteries, each one real, each one confirmed, and each one leading to questions that still have no answer. The deepest point on Earth is not a dead end. It is a living, changing place, still writing its own story. As the sun sets on the surface, the deep below remains unchanged, a world apart from the rhythm of our days. Even a single grain from the deep carries the chemistry of the abyss, a fragment of a world we are only beginning to understand. The same forces that built the trench still move beneath it, and the planet is never still, even in the deepest dark. In the dark water, the ocean reminds us that light can exist even in the deepest places, if we know where to look. The Mariana Trench is one of many frontiers, and the ocean still covers most of our planet, waiting for the next generation of explorers.
The file is closed. The mystery remains.